So today we are talking about kinematic equations. What are these equations and when we use them, and also we will solve some problems using these equations. By now there are four quantities associated with the motion of objects. We talk about distance, we talked about the velocity and speed, we talk about acceleration and time. So we have four quantities. These four quantities, distance, time, acceleration, and velocity, can describe the motion of an object. So then by the knowledge of these quantities, you can describe the information or describe the object or the moving of an object. For example, if a car is known to move with a constant velocity of 22 meters per second north for 12 seconds for a northward displacement of 264 meters. So here, as you see, you have a velocity of 22 meters per second. You have a time with a 12 seconds. You have a distance with 264. So you can describe now, or you can you have enough information to describe the motion of the car. So if you want now to describe the motion of the car, you need four quantities: velocity, acceleration, time, and distance or displacement. These equations, we call them the big four. The big four, that means it was four equations. The kinematic equations are a set of four equations that can be utilized to predict unknown information about the object's motion. I mean, all of us know that if I need, or if I have D, if I have T, I want to find V. In physics, I need a formula. So these equations here, he told me that if you know the distance and if you know the time, you want to find V, you say yes, the velocity here is the distance over time. So you can find or predict the unknown information about an object motion if other information is known. Since you know D and you know T, so you can find V. Before that, all of us know that the velocity is d over t, and the acceleration is v or the delta v over delta t. Now, if you have now A and D, acceleration if you know, as an example, the acceleration, you know the distance, you know the V initial. How can you find the V final? Can you use this equation, the acceleration equation, or this one? If you have acceleration, displacement, V initial, and you ask you about V final, can you use this one?
We can use the second one.
Not either. No, Ella, here there's
I didn't get your question.
Okay. Let's see here. If you have now, if I'm asking you, or if I give you the acceleration of a car, and I give you the distance, that's the car's movement or the displacement of the car, and I give you the V initial, and I'm asking you about V final. Our previous formulas told me that if you want to find the velocity, you say it is d over t. And you know, if you know the acceleration is v over t, or v final minus v initial over t. So can you use the first one?
Use the acceleration.
You cannot use the first one because d here is not written, and you cannot use the previous one because a is not written. That's why they differentiate, or they find these four equations, and they name them with the big four. So these equations can be utilized for any motion that can be described as being either a constant velocity motion. What does it mean? That means these big four equations cannot be used anywhere. It can be used only if you have a constant. If you have only a constant velocity motion, or I mean constant acceleration. Here, if you have only a constant acceleration, you can use these equations. But if the acceleration is changing, you cannot use this equation. These big four equations can work only if the acceleration is constant. But if the acceleration is changing, you cannot use it.
Teacher,
So
do you mean like when the velocity changes, the acceleration will change?
No. Here I'm talking like you move on a street as an example. You know your V initial, you know your V final, you can find the distance, the time, so you find the acceleration. So your acceleration here is constant. Either you are here or here or here. But sometimes if you start slowly, then you increased your velocity. So the acceleration at the first here is not equal at the acceleration in the second path, because your delta, or your changing in velocity, is changed. So this example is only if the acceleration is constant. If it is constant, either are you in the exit 1 or in exit 2 or in exit 3 or in exit 4. Your acceleration is constant. That's mean, I will give you another example. That's mean you start from 0, then 40, then 80, then 120. Okay? If you find the acceleration during this interval from 0 to 40, it will be the same during this interval. Okay?
Yeah, like they have the same speed.
So because it's the same, because here the acceleration is constant, I can use this big four equation. But if the acceleration is changing, and we will talk about it later on in the next chapters, I cannot use these equations. So they can never be used over any time period during which the acceleration is changing. Each of the kinematic equations include four variables, which is d, t, v, and a. If the values of of the four variables are unknown, so then the value of the fourth can be calculated. Let's see now, what are these equations? What are these equations that help me to find the unknown information? Let's see them here. The first one, that the displacement, or the distance, is equal v initial times time, v initial t, plus half a t squared. Here, what does it mean? If you know the time, if you know the acceleration, if you know the v initial, and you want to find d, you can use this formula or this equation. Or if you know the initial, if you know the displacements, if you know the acceleration, and I'm asking you to find t, you can use this equation too. So the four variables that is written in this equation are t, time, A, acceleration, VI, which is a V initial, and D, which is the distance. The second one now, V final is equal to V final squared, sorry, is equal to V initial squared plus 2AD. Here, if I have V initial as an example, and I have V final, and I have the acceleration, and I'm asking you to find D, you can use this equation. The first one here, so how can I solve it? I look at the question. If the question give me the V final, the V initial, the acceleration, and ask me about the distance, I will use the second one. But if he give me the time, the acceleration, and the V initial, I will use the first equation. Is it clear?
Yes.
Teacher,
Yes.
the first equation, didn't they deduced it from the graph of velocity versus time, right?
Yeah.
Because it looks like a triangle.
Yes, it is. I told you it's derived. I mean like this one here. The V final equal V initial plus A times T. We said before that the acceleration is V final minus V initial over T. Oh, before, let's wait, Susan, please. For these two, the first two equations, did you understand that?
Yeah.
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 As there one told me I didn't understand. Is that right? Girls, I hear someone told me I didn't understand. Is it right?
No. Nobody said.
Okay. So the first and the second one here, this is the physics that I told you about. In the physics here, you have a given information. Then after that, in this given information, you ask yourself, what is the information I have? And what did I need to find? And which equation shall I use? That's why, like, a physics is a language of math. Because in physics, you need math. In the word problem, in the algebra or in geometry, you read the word problem, you would look, what did I need? What did I have? The given for me is T, A, V initial. And he asked me D. So which from these equations shall I use? Shall I want to use the first one? Sometimes, so if you look at the first and the second one here you have, wait, I want to change the color. Here you have D and here you have D. What's that mean? That's mean if I'm asking you to find the distance, you have only to use the first and the second one. You cannot use the third and here also this and the fourth one. But this one, you cannot use it because if you use it, you don't know, or we cannot find D. And also for the others. As an example, A, the acceleration A here, if I'm asking you to find the acceleration now. Here you can't find the acceleration. Here you can't find it. Here you can't find it. But here you cannot. So the fourth equation cannot help me. And when we solve problems, inshallah, you will understand more and more. But for the first two, here now, you have, if you have these three, at least three, it must be have three, and you want to find the fourth one, you will have use the first equation. And here also, if you know V initial, if you know A, if you know D, and you want to find V final, you have to use the second equation. Let's talk about now the third one. In the third one here, all of us know that the acceleration is change v over t. So I can say now A is v final minus v initial over t. If you multiply them, what did you will get? You get v final minus v initial equal A times t. Is it right? Using math now. Then if you move this v initial in the second side, you have v final equal v initial plus A times t. So for this equation here, that's mean that's the third one here. Here we derive this equation by using the one that we know it before. So v final now is v initial plus A times t. If you have t time, if you have the acceleration, if you have v final as an example, you need to find v initial, you will use this equation. Now, let's talk about the last one. In the last one here, the distance is v initial plus v final times over 2 times t. Here, if you have v initial, if you have v final, if you have the time, and you need to find the distance, you can use this formula. Is it clear now?
Yes.
Yeah.
Let's have
Teacher,
now problems. Yes?
which formula do you use to find the V initial?
The V initial, as you see here, you can use it by the first one and the second one and the third and the fourth. All of them can help me to find V initial. And the second one and the last one and the here, you help me to find V final. Let's see now how can we solve them using the word problem. Okay. Okay. And now let's start with the first one. An airplane accelerates down a runway. No, I think this one. Is it flow? Wait, please give me 1 minute. Okay. Now, an airplane accelerates down a runway at 3.2 meters per second square. So the acceleration here is 3.2. For 32.8 seconds. Second is a unit of time. So T here is 32.8. Until it's finally lets off the ground. It starts to move from a point until it reached the ground. Its acceleration was 3.2, and the time that takes to reach the ground is 32.8 seconds.
Teacher?
Yes?
Teacher, is A is the initial?
No, A is an acceleration.
Yeah, okay.
Now, I want you now to determine the distance traveled before takeoff.
We can use the formula half AT squared plus V initial by
Wait.
T.
I want to see first. Here now, I have an airplane. It starts from up, it goes down until it finally lifts the ground. What does it mean? What is the V final here when it's reached the ground?
Teacher, isn't takeoff like it is on the ground and then it flies?
It's flying.
Oh, sorry. Yes, sorry. So here now, there's an airplane. It starts from down and it's go up and it's take off. Okay. So here, this is my airplane. It accelerates down a runway at 3.2. So the acceleration here is 3.2. The time is 32.8. And until it's finally left the ground, determine the distance traveled before takeoff. So what is the V initial here?
0, because it started to rest.
It is 0. So from here, I used now. Oh, why I
Now
started?
we find the final
Here now,
initial.
I ask you now that if you want to use these equations, you have to 4 variables. The first one is A. The second one is T. He asked me about D. So I need a 4th variable. From where I bring it? From the question. He told me that when it starts to move. So V initial here, it is 0. Then, now after that, I look at these equations, the big 4 equations. I will find, now let's search, or let's look at the, not the one, look at the second one. The second one, he told me that, this is the second one, okay? Here, I have to write it now. The second one, which is V final squared equal V initial squared plus 2AD. A is written, D is written. I want to find D. A is written. V initial is written, but I don't have any information about V final. So can I use it?
No.
But isn't there an equation that says that V final is equal to V initial plus the time multiplied by the acceleration?
This one here? The third one, you mean?
No, V final. There was an equation that said it is like V initial plus AT.
Oh, yes, this one.
Yeah,
The third one. V final equal V initial plus AT. For this one here, if you use the third one, A is written, is given, sorry. T is given. V final is given, but this equation helped me to find V final. I don't want V final, I want D.
Yeah, we can use half AT
So-
squared plus VRT.
So, what should I do now? I look about these 4 equations. Okay, I look at now these 4 equations. Which equation helped me to find D?
The last one?
The second one, we said before that we cannot use it.
The first one.
The first
I
one.
cannot use it. Look at the last one here. Also, I need V final, so I cannot use it. So I have only this one. Now, by now, all of us understand from how or which equation can I use? Do you understand how?
Yes, no.
Eh?
Why the last one no?
Because here I need V final, and V final is not given. Did you understand?
Yeah.
Okay. So let's take now the first one. D is V initial T times half A T squared. D is unknown. I have to find it. Okay, V initial. Where's V initial? It is 0 times T, which is 32.8 plus half. What is A? It's 3.2. And what is T? It's 3.8 squared. Now, 0 times any number is 0. Then you have to multiply, or to find 32.8 squared. Then you multiply it by half. Then you multiply it by 3.2. After that, you will find that the distance now is 1,720 meters. Is it clear now?
Yeah.
Yeah.
Okay, I have to analyze the question. I need 4 variables. Every time I need, every equation give me 4 variables. So I need at least, or I need 3. If there's no 3, I have to look about the third one. From the question here, I can find that V initial is 0. So I can now know the last of the third variable. Now let's talk about the second question. In this question here, a car start from the rest. What does it mean? If I'm talking,
At the initial.
told you,
Yeah, the initial is 0.
start from rest. Every time, if you see this word, car starts from rest, that's mean V initial is 0. Sorry, Maya?
It means that V1 is 0.
Yes, thank you. And accelerates uniformly. This words that mean it has a constant acceleration over a time of 5.21 seconds. So the time here is 5.21 seconds for a distance of 110. I have T, I have D, I have V initial. I want now from you to look at the big 4 equations and tell me which equation shall I use. I want Habiba. Habiba, which equation shall I use now? You have V initial, you have T, and you have D, and I'm asking you now to determine the acceleration. I'm asking you to find A, the acceleration. So which equation shall I use?
The first one.
The first one, thank you. The first one here, D is equal to V initial T plus half A T squared. T is written. Where's T? It is 5.21 squared. A, where's A? I have to find it. Times half. Plus, where is T? It is 5.21.
5.25.
V initial, it's given. It is 0. And the distance is 110. Then this is 0. So 110 is equal half A times 5.21 squared. Now, 5.21 squared multiplied by half is 13.57. 7 times A. If you multiply this one 2 times, then divide it by 2, you will get 13.57 by calculator. Then after that, divide by 13.57, divide by 13.57. So the acceleration is 8.1 meter per second. Is it clear?
Yeah.
Yeah, teacher, shall we write 8.1 or only 8?
If it is an essay, write 8.1. If sometimes it's a multiple choice and you have 8 only, choose 8.
Yeah, okay.
Okay, now Sarah, Lama, did you understand these equations?
Yeah.
Teacher, when I read our book, were they written?
No.
Yeah, this is like I was really surprised.
This is not in your book, but if you find some, or if you look at the questions, you will find that like give you like these questions, but you know, like I don't know the book. They ask me to give you everything, but it's not written from your book. And then at the end of the chapter, they ask you about it, and then you go back, you didn't find these equations.
I found
Oh
it
no,
in
I didn't like our book.
Like teacher, we should study all these equations, right?
Yes. But at the end of your chapter, you will find some questions like this. But the kinematic equation, it's not written. This is your book.
Can't we change it? Like, it focuses more on the conceptual part of physics and it completely doesn't mention the equations or the laws.
How can I change to what? To Harcourt, and in our school we have to use person. What should I do? This is the book. This book, they give it to me, and I have to learn you. That's it. But we can't change we cannot change it because we cannot change the physics only to Harcourt. That's the problem. But they told me that Harcourt is more easily and they describe everything more clearly.
Yeah, it has more description.
Yes, yes, it does.
Yeah, so the other girls come from
I'm
House of
reading
Language. I think Yara, she know it. House of Language. Darin, she told me last year that the Harcourt is easier and more clearly than the person one. But I have to teach it. Okay, now you're back. So let's continue now. Wait, please. Now this one here. A car accelerates uniformly from 18.5 meter per second to 46.1 meter per second. Look at the units here. Meter per second. So it is a unit of velocity, is it right?
Yes.
Now, the car accelerates from something to something. That means this is V initial and this is V final in 2.4 seconds. So this is the time. I have V initial and I have V final and I have a time, and he asked me to find the acceleration first, then the distance that is traveled. Let's now talk about the first one, the acceleration. If you have the initial, the final, and the time, and I'm asking you to find the acceleration. Yes, Rose, which equation should you use?
The last one.
The last one. I want to find A. The last one, it will give me A.
The third one?
The third one, thank you. V final equal V initial plus A times T. V final is written, it is 46.1. V initial, it is 18.5 plus A, where's A? I have to find it, times T, which is 2.47. Then 46.1 minus 18.5 is equal to 2.47A. I just move 18.5 to the second term. Then after that, 46.1 minus 18.5 is 27.6 is equal to 2.47A. Divide by 2.47, divide by 2.47. You will know, or you'll have now that A is equal to 11.17 or 11.2 meter per second square. So now I have A. How can we find D?
Half AT squared plus V initial multiplied by time.
Thank you. We will use the first one.
Can't we also use the last
The last one, yes, you can also use the last
Can
one.
we use the last one?
Yes, we can use it, yes. So now I want to, and you can use also the second one.
Yeah, because we have acceleration now.
So let's choose now the first one, V initial.